Okay, so this is a section on quadratic inequalities, and it is where we compare our standard quadratic equation, alright, and we look where it will be greater than 0, okay, or where our quadratic equation is less than 0. Now, I just need you to remember that when we have a quadratic equation like 2x squared plus 5x plus 6, that refers to the parabola function. But more so, when we have the entire equation as is written here above the rainbow colors, we are actually saying where is the y value greater than 0 and where is the y value less than 0, because ax squared plus bx plus c refers to a specific parabola. Alright, so long story short, it says here that when I talk about your graph being greater than 0, okay, that is everything above the x-axis, which is down here, as you know, right? So for a specific parabola like this one that is concave up, this graph is above the x-axis, right? The y values are greater than 0, and it happens over here on the left, okay? But it also happens on the right. And so a parabola where we say ax squared plus bx plus c greater than 0, that will occur on the left hand side, so there it will happen, and on the right hand side. Okay, so now the question is on the left hand side and right hand side of what? Of our roots, or as you call it, your x-intercepts. Okay, and so this parabola is above the x-axis towards or to the left of the one intercept and to the right of the other intercept. Okay, the second scenario is when I ask about, or where you want to know where is this parabola below the x-axis. So when they say, okay, where is y less than 0, where is y negative, that happens down here. All right, and as you can see, that is occurring between xl, which is the left x-intercept, and xr, which is the right x-intercept. Let's try one with a parabola that's fully drawn. Okay, so over here we have a parabola, and this parabola has roots that are known to us. The one root, or the intercept, is at -2. The other one, let's say this is at 4. Okay, it's just a bit off, but let's round it up. So let's say the first question is, where is x squared minus 2x minus 7 greater than 0? Okay, so first of all, this greater than 0 tells you you want to look above the x-axis. Okay, meaning you want to see where is this function, this parabola on our left, above. Well, it's above here in this section, and it's above here in this section, meaning it's happening on two occasions. It's happening when the x value is bigger than 4, and then it happens again when the x value is less than 4. So for all those values, when x is greater than 4, or when x is less than -2, that is where your parabola, right, x squared minus 2x minus 7, this guy will be above the x-axis. All right, then the second question could be, well, where is x squared minus 2x minus 7 less than 0? Again, the less than 0 is asking about the connection to the x-axis. So this is below the x-axis, okay? And that happens down here in this section, right? And this answer is nice because it's happening between the two values. And because the occurrence is between, we write it exactly as such. We say that x is less than 4 and greater than -2. So that is referring to the section over here, right? Between -2 and 4 is where this graph will be below the x-axis. Now I just want to show you another form of this question. If they were to say greater than or equal to, the only difference is that you add the equal to into your answer. If they say less than or equal to, it's the same process. You just need to add the equal to. Okay, so in your examples, you will have the equation of your function. You have the quadratic form. You just have to calculate the intercept. Okay, that's it. You just have to work out what is the x-intercept by making your quadratic equation equal to 0. And then you factorize that, and then you get your two answers. So that is what we're going to do in the next video.